Welcome back. We are studying the concept of slope today, and our objective is to be able to find the slope of a line. A couple of new vocabulary words for you are slope, rise, and run. Those are items that you can include in your Kim sheet with their definitions. And we have an example on this page with a ladder truck, and it says it uses a movable ladder to reach upper levels of houses and buildings. The rate of change of the ladder compares the height that it is raised to the distance of its base from the building. And the question asks us to write this rate as a fraction in simplest form. Okay, so the fraction that we want to write, it tells us to give the ratio of two things. And it says the rate of change is the height here and the distance that it is from the base of the ladder. So that fraction would be the height, which would be 45 feet, divided by the distance from the base, which would be 30 feet. Okay? Excuse me. So that's the rate as a fraction. We can simplify that, however. If we divide both of those by 5, that simplifies to 9 over 6. And we can simplify even further by dividing by 3, and we get 3 over 2. Okay? So the second question says, find the rate of change of a ladder that has been raised 100 feet and has a base 50 feet from the building. So this one's going to be similar, just different numbers. So this one we have 100 feet it's raised. So we're going to go up 100 feet. And this one is going to be raised, or a distance from the base is 50 feet. And so if we reduce this one, we get a rate of 2 to 1. All right, so this fraction that we just did, comparing those two values, is called the slope of the line. And the slope of the line is the rise over the run. The rise is a vertical change, and the run is a horizontal change. Couple of items relating to the slope of a line. The slope is a constant. It never changes. It's a number, just a numerical value. It's usually a fraction. It's a rate of change. And it can also be either positive or negative. And those lines show you a positive or a negative slope, what that looks like. Here's an example with a treadmill. It says, find the slope of the treadmill at the right. Well, it shows in the picture that the treadmill is 48 inches long and it's raised up 10 inches. So the slope is the rise over the run. That's the definition of slope. So the rise would be 10, the run would be 48, and if we simplify that, we end up with 5 over 24, so the slope of the treadmill is 5/24. Now here's an example for you to try. This one says a hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope of the hiking trail? Go ahead and pause the video and see if you can figure this one out. All right, so the rise over the run, we're going to get 6 over 100, and when we reduce that, we get 3 over 50. Finding the slope using a graph. To find the slope of the line, we can choose any 2 points on the line over here. This blue line, we chose points A and point B. And the vertical change, if you just make a little triangle to get from one point to the other, you go up 2 and you go right 3. So the rise over the run is 2 over 3. So the slope of the line is 2/3. Now one of the things I want to mention here has to do with directions and whether they're positive or negative. Going up is a positive direction. Going down would be a negative direction. Going to the right is a positive direction, and going left would be a negative direction. So make sure you understand the positive and negative direction so you get the proper slope and the sign for the slope. It's very, very important. Here are a couple of graphs for you to try. Go ahead and try to figure out the slope of these lines, and I'll give you the answers when you come back. All right. On the left-hand side, it looks like we're going up 1, 2, 3, and to the right 1, 2, 3, 4. So both positive directions, so our slope is 3/4. On the second graph, you can see that the direction is different, so we should get a negative slope, and that's because we went -2 and up 5, or you can think of it as going down 5 and right 2, so our slope is -5/2. It doesn't matter, one of the things I want to mention, it doesn't matter where the negative goes. You can go from this point, you can go down 5 and right 2, but you can also think of it as starting at this point and going left 2, which is negative, and up 5, which is positive. You still get the same value. Using a table to find the slope, here we have a table on the right, and it says the points given in the table lie on a line, find the slope of the line and graph the line. Two ways to do that, and we're not going to do the graphing part of that in this slide. We'll do that later on. Using the slope formula, the slope formula says we take the change in y, divide it by the change in x. Well, the change in y over the change in x, if you pick any 2 points, okay, in this instance we picked 9 and 12 and 3 and 1. So we start with 9, we subtract 12, and then we start with 3 and subtract 1, and that gives us a change in y value of -3 divided by the change in x value, which was a +2, so the slope works out to be -3/2. Now if you just take a look at the table itself and analyze the table, you can ask yourself, well, how is x changing? And it's going up by 2 every time, and y is going down by 3 every time. So if you just analyze the table that way, you end up getting the slope of -3/2 as well. So either way works. Here's a couple for you to try on your own. I'll pause the video and I'll give you the answers when you come back. Alright, to do the analyzing the table, the y values look like they're going up by 1 every time, so your change in y is a +1. Changing in x, it looks like those are going up by 4 every time, which gives us a slope of +1/4. And using the slope formula, we're going to do the second one this time. Okay, using the second table. The change in y divided by the change in x, we're going to pick the first 2 points. So we're going to take -2 minus a -1, and then we're going to take 0 minus a -4. Now watch your signs in here. It's very easy to get confused. The minus a minus is always a plus, so make sure that you recognize where those signs are coming from. Right here, these two right here turn into a plus sign. Same thing in the denominator. Minus a minus makes that a plus. So remember, I'd like you to always be using just one sign. So change those signs to whatever sign it is, whether it's plus or minus. So this gives us a slope of -1/4. And one of the points over here on the left that I want to make sure you understand as well, you can choose any 2 points to calculate the slope. We've been choosing the first 2, but you can choose any 2 points in the whole table. And make sure whatever points you use, if you start with this y value, you start with that x value in the denominator. Okay. We've been using slope, finding the slope using rise over run. There's also a formula that we use to find the slope. We've actually used it, but now I want you to make sure that you understand just what the terminology is, or the formulas. And this one uses some subscripts, so I just don't want you to be afraid of what these x1, y1s are. The slope of a line passing through points x1, y1, and x2, y2. The x1, y1, those are just subscripts, and it just tells you that they're different points. They have different coordinates. Okay, and it's just the ratio of the different points. Okay. So let's do some examples. Find the slope of the line that passes through each pair of points. So we have our formulas here, and we're going to go ahead and start with the point D and then to the point C. So we're going to do y1, or excuse me, y2 minus y1, and then x2 minus x1. I'll go ahead and draw some arrows in here. That might help us keep things straight. So those are our y values right there that we're changing, or subtracting, excuse me. And then these are our x values in the denominator that we're subtracting. So what we end up with is 2 minus a -4 and 2 minus a -1. And change your signs, you end up getting 2 plus 4, which is 6, 2 plus 1 is 3, or 2. Over on the right-hand side, we get 3 minus 2 in the numerator and a -4 minus 1 in the denominator, giving us 1 over -5, Or you can put that negative out front and just get -1/5. Here are 3 more for you to try on your own. Please bring your answers to class, and I'll see you next time.